Hello, I would like to talk about percent solutions. Percent solutions, it's some percentage of some chemical in the solution. Usually it's given grams of solute for 100 milliliters of solution. Most likely this is water, but not necessarily always water. Prior knowledge. This is the stuff that I think you need to know before you come into this, and I know you already know if you've been in my class very long. But 1 molar solution. A 1 molar solution is however many grams to moles of the solute in 1 liter of solvent. 1 liter is 1,000 milliliters. Now we're going to come back to this one all day long. 1 liter is 1,000 milliliters. We're going to consider the ocean. The salinity of the ocean is roughly a 4 to 6% solution. And I know the ocean has all kinds of stuff in it, but we're only going to talk about the salt, just NaCl. Now, let's figure out exactly what we're doing. I think at this point we can all get to NaCl has 58.5 grams per mole. So let's look at this, how to figure this out. If 4% solution is 4 grams in 100 milliliters of water, then we can say, I could stick a 0 on both sides of this. So it's 40 grams in 1,000 milliliters, and here we are with a liter, and it's 40 grams per liter. So the easy schmeezy way to look at this is if you've got 4 grams, add a 0 and stick it in the liters. That will work. So now we've got salt. And 1 mole of NaCl is 58.5, and you recognize this. Now we have the 40 grams we stuff in right there and find out that 0.68 molar. That's the molar of the 4% solution. Now, I'm not going to do the math for you on the 6% solution. You have a little sheet that you can write that down on. But I will tell you the answer so you'll know you're right. Please show your work. I'm not kidding. Please show it. So if a 4% solution was 0.68 moles, a 6% solution is 1.3 moles. And so we know that the molarity range of the ocean is between 0.68 and 1.3 molar. Isn't that interesting? Things you need to know. Alrighty. Whoa. Whoa, I am not going to let that fall. Sincerely. Yay! Percent solutions in a saturated salt water. Now, they have discovered that at STP, that standard temperature, standard pressure, 35.9 grams of salt will dissolve in 100 milliliters of water. What is the percent solution? This is so easy schmeezy because it's those many grams over that much liquid times 100 is 35.9% solution. Yay! What molar is that? I expect the molarage to show up on your sheet, but I'm not going to tell you the answer right now. We've been over that one in class. Alrighty. I didn't lose that one. That's great. A 15% nitric acid. What molar is that? My daughter says that's a real-life equation. Cool. So first of all, what is nitric acid? It's HNO3. And so now we can figure out all of that stuff to find out that it's 63 grams per mole. All right, we can stuff it into this solution. If you've got 15% solution, just add a 0, stuff it in a liter. So now we've got 150 grams that we can put in this basic equation that we know all about. So 1 mole of nitric acid is 63 grams. We've got our 150 grams and we find out molar. Please show all your work. please use your units. I love units. They help me. So now, how? This is what I did today. I am figuring out how to make a 6% solution from a 30% solution of hydrogen peroxide. Hydrogen peroxide, H2O2. So now I have already calculated my H2O2-ness and found that it is 34 grams per mole. So here I go. I need to figure out the grammage in 6% solution. Add a 0, stuff it in a liter. I'll go ahead and do my 30% solution, add a 0, stuff it in a liter. Cannot get easier. So now you do your basic molarity equation. All right, so the 6% solution is 1.76 moles. The 30% solution is 8.82 moles. And now we scratch our heads and go, what does that tell us about making this solution? And here's another prior knowledge, because you guys have been there and done that. And here it is. Dilution's equation. So dilution equation is this guy, to where you have mass of the dilution, volume of the dilution equals the mass of the concentration times the volume of the concentration. We're solving for volume of the concentration. I want to know how much of that 30% solution I'm going to use to make the 6% solution. So here's my equation all set up. This is a very important step. So now I know exactly where to put my numbers. So I put my numbers thusly and find that I am going to use roughly 20 milliliters of the 30% solution to make my 6% solution. How am I going to do it? Well, the easy schmeezy way says 100 milliliters is what I'm looking for. I'm using 20 milliliters in that 100 solution, so 80 milliliters left. I ran out of room, and I still want to tell you that when you are writing that down in a testing situation or on a lot of your papers, the accurate way to do this is to pour the 20 liters in a flask and fill to the 100 milliliter mark. When I actually did this in my lab to make this solution, that's exactly what I did. I measured my container. I knew where my 300 milliliter mark was, and so then I filled it up. I needed 300 milliliters, so I put 60 milliliters of my 30% H2O2 solution in there and then filled it up to that mark that I already did. So that is a percent solution and all kinds of things about it. Thank you.